I am going to do this problem two ways. The first is just how I visualize this. The square root of 72. Well, I'm always looking for perfect squares that go into 72. And the first one I recognize is 9. So I would rewrite 72 as the square root of 9 times the square root of 8 times the square root of m to the 4th power. And the square root of 9 is 3. And the square root of m to the 4th power is m squared. But I still have the square root of 8. Well, the square root of 8 actually can be written again as the square root of 4 times the square root of 2. And now I have 3 times the square root of 4, which is 2, square root of 2, and I still have that m squared. So in this case, I'm left with 6 m squared, the square root of 2. Now that's how I broke it down initially, but then once I saw this 6, I realized that a higher square root than 9 and 8 went into this. And indeed, looking at this again, the square root of 72 m to the 4th can be rewritten as the square root of 36 times the square root of 2 times the square root of m to the 4th power. And now 36 times 2, since that's 72, I can go directly to my square root of 6 m squared, that comes from the m to the 4th, and the square root of 2. So I get the same answer in both cases, but why I wanted to show you this first case is to say, it's okay if you don't always recognize that highest root that goes into this. Sometimes you need to do square roots or even cube roots 2 or 3 times until you get it down to its lowest simplification, its most simplified form.